This video tutorial will teach you how to perform a yeast cell count and calculate the pitch rate for your brew. Achieving a cell count requires these key pieces of equipment: a microscope with 40x objective, 0.01% methylene blue solution, a hemocytometer and its clean dry cover slip, a vortex, a handheld counter, and pipettes. Vortex the diluted yeast sample. Draw a sample of the homogenized yeast cell suspension and keep track of any dilutions made for later calculations. For example, when dealing with yeast slurry, dilute 1 milliliter of the slurry in 99 milliliters of water. Mix the sample in a ratio of 1:1 with 0.01% methylene blue solution. Mix the sample until the color is uniform. Allow it to sit for 1 to 2 minutes. After 1 to 2 minutes, be sure to re-homogenize the suspension before pulling a sample for count. Draw 1 milliliter of your homogenized stained yeast suspension and begin filling the hemocytometer from one of the wells. Fill the sample until the field of view under the cover slip is full. View the counting field under the microscope using the 40x objective. Blue cells are non-viable, clear are viable. In the next section, we will take an in-depth look at cell counting. Locate the central square with 25 smaller squares, each of which are themselves gridded in a 4x4 pattern. Count the total number of viable yeast in 5 of the squares, using the pattern shown here in the green squares. If yeast are clumped, you may use a declumping agent, for example, sulfuric acid and EDTA for dilution, or count 25 squares for the accurate sample representation and calculation. Exclude buds and yeast lying on any 2 of the adjoining 4 borders of each of the 5 squares. In this example, we are using the left and bottom borders. The yeast cells touching the middle line must be excluded from the count. Inversely, the opposite borders require that you count the cells touching the middle line as shown. Yeast cells that are budded are counted as one cell if the bud is less than 1/2 the size of the mother cell. Confused about making dilutions and calculating dilution factors? Consider a 1 to 10 dilution. The number on the left side of the colon is the volume, in milliliters let's say, you begin with. The number on the right is the volume you end up with. A dense slurry may require a 1 to 100 dilution, namely, the addition of 1 milliliter yeast to 99 milliliters water in order to render it countable. There is another way to get a 1 to 100 dilution. You may add 1 milliliter yeast to 9 milliliters of water, mix, then remove 1 milliliter of that suspension and add it to 9 milliliters of fresh water. In other words, 2 1 to 10 dilutions made in series are equivalent to a single 1 to 100 dilution. Likewise, 3 1 to 10 dilutions made in series are equivalent to a single 1 to 1000 dilution. The dilution factor is the product of the numbers on the right side of the colon. For example, a 1 to 10 dilution followed by a 1 to 4 dilution is equal to a 1 to 40 dilution and has a dilution factor of 40. Now, let's perform a simple calculation. Let's begin with a slurry density of 120 cells that were counted in 5 squares. Multiply that number by 50,000. That's the volume under the cover slip. Then multiply that number by 100. In this example, this equates to 600 million cells per milliliter. Now we need to calculate the slurry volume. For this example, we'll use 4 gallons of slurry. Multiply 4 times 3,800, which equals 15,200 milliliters. Finally, we need to know the total cells available for your needs. Multiply your previously calculated slurry density, which was 600 million cells per milliliter, times your previously calculated slurry volume, which was 15,200 milliliters. In this example, we have 9.12 times 10 to the 12 total cells available, which is 9,120 billion. In order to find out how many cells are required for your fermentation, let's start with your wort. To figure out your pitch rate, in this example, we'll use the Plato of your wort and multiply it by an industry standard for ales of 1 million cells per milliliter. Now, multiply the Plato of your wort by 1 million cells per milliliter to get your pitching rate of 12 million cells per milliliter. Next, we need to determine the volume of your wort in milliliters. Multiply in barrels the amount of wort you have. In this example, we used 15 by 31 gallons per barrel and then again by 3,800 milliliters per gallon. This example calculation resulted in 1,800,000 milliliters. Now, to calculate the total cells required for a quality fermentation, we start by multiplying your pitch rate by the wort volume we previously calculated. This results in our total cells required, which, in this example, is 2.16 trillion cells. Pitch rates depend upon yeast type and beer specifications. For example, ales below 16-degree Plato receive 1 million cells per milliliter per degree Plato, whereas lagers below 16-degree Plato receive 1.5 million cells per milliliter per degree Plato. For ales and lagers above 16-degree Plato, special recommendations from BSI will need to be considered.